Alright, welcome back to part 2 of our lecture about winter weather. And now we're going to talk about another form of winter precipitation, namely rain. And we're going to make another one of these graphs where temperature is going to be plotted on the x-axis versus height as the y-axis. And it's probably not, again, we're not going to get all bogged down into exactly what the scale is and so on, so much as just to notice where the freezing line is compared to the temperature that you are plotting. And what I want you to notice is we have a pretty thick layer near the surface of the Earth where the temperatures are above freezing. Our weather balloon and radiosonde noticed that there was a fairly thick layer near the surface where the ice crystal falling from starting up by that letter R in the word rain and working its way down. It started off as an ice crystal, hence the X, but as it got closer, and it may even have fallen for a while through a layer where temperature was above freezing, but eventually that thing melted, and our symbol in meteorology for raindrop is a dot. It's just a period, so I switched to using a dot there. As that raindrop falls and falls and falls and then reaches the ground, it's in the form of liquid rain. I don't think that's a huge shock. Basically, if the ice crystal falls through a thick enough layer of warm enough air, it melts and you have rain instead. I don't think we need to bog down too much with rain itself, so much as to talk about freezing rain. Now, freezing rain is another type of winter precipitation. For what it's worth, the symbol for freezing rain is sort of this sideways S with a dot under it. Kind of looks like an eyebrow to me. I have no idea what that symbol is supposed to look like, but it's the standard symbol in meteorology for freezing rain. Freezing rain, if you're not familiar with it, first off, if you're not familiar with it, you know, where'd you grow up? Because I'd like to be there. But freezing rain is precipitation that hits the ground or the surface or the trees or whatever as a liquid and then freezes on. So freezing rain is not like frozen raindrops, it's rain that hits the ground and then freezes on. And if we were going to be making another one of these kind of diagrams where we are showing the temperature on the x-axis with respect to height, like what might have been observed from a radiosonde and weather balloon, what we would see is a curve like this, where again we're going to start with an ice crystal up near the top of the diagram, like by the E in freezing rain, and it's falling and it's falling and it's falling, and eventually it hits the layer where it is falling through temperatures that are a little above freezing, and at some point it will have a melting level where it has changed from ice crystal to a raindrop. So notice how I switched to using a dot for my symbol because now it's liquid. But as you get close to the ground, suddenly you encounter a layer of the air that is temperature is decreasing as you get closer to the ground, and in fact temperature is below freezing at the ground. Hey, remember the powerful vocabulary word here? We have a temperature inversion near the surface where temperature is increasing with respect to height. So the precipitation will have hit the ground as a liquid. It didn't have time. You know, there might only be a few tens of meters thick, that layer near the surface where the temperatures are below freezing again. Well, the raindrop crossed that in a few seconds. It didn't have time to freeze as it fell through that shallow, cold layer. But once it's on the ground and there's a little bit of time, it can freeze. So there isn't time for the droplet to refreeze as it passes through that cold layer, but once it's on the ground, and you know, it takes another 10 seconds or something before it freezes on. Notice that what the requirement here is. There's no way to get that kind of freezing rain without that temperature inversion near the surface, because you needed to have a layer up above the ground where it was warm enough to melt this ice crystal into liquid, and then near the ground you need to have cold enough air to freeze it again. So you have to have a temperature inversion, and specifically it's going to have to be a pretty shallow temperature inversion, so that there, you know, if there was a thick layer near the ground where the temperatures were cold, we'd refreeze that raindrop on the way down and get something else. We'd get sleet. So we're going to instead get freezing rain because it's just a shallow temperature inversion near the surface. Freezing rain, of course, is a disaster. That is really the one that is a paralyzing weather event for transportation and trees. It tears down trees, it tears down power lines. It's hard to scrape off of windshields. It's very difficult to get off roads without just salting it or graveling it. This is the one that is, you know, most alarming when it comes to winter precipitation. Our fourth type of winter precipitation is sleet. And the symbol for sleet's kind of cool. See how it's like a dot with a triangle around it? Sleet is a frozen raindrop. It is a liquid water droplet that fell through enough cold air near the surface that it refroze again. And it starts freezing on the outside of the raindrop, and because that's the part that's in contact with the cold air, leaving a liquid center. And by and large, actually, when they reach the ground, they will still have a liquid center. I don't know how you would prove that. You'd have to get like a little scalpel out and see if you can cut one open. But generally speaking, sleet hydrometeors, the things that are falling from the ground, the sleet particles, are solid on the outside with a little core of liquid on the inside. Again, in like a 500 level physical meteorology class, I'd love to explain to students why that is, but that's not where we can go in a 100 level general science survey course. Sleet are hard little pellets of ice. In fact, a good word for sleet is ice pellets. They're kind of dull gray, and they're hard. You pick them up with your fingers, you can't crush them. Okay, they are hard little balls of ice. They make thunk, thunk, thunk noise when they hit your windshield. Okay, they are going to happen when ice crystals, up there by like the letter S in the word sleet, are falling through the atmosphere and start encountering temperatures that are warmer than freezing. And so after falling through a small amount of that layer, the ice crystal melts into a liquid water droplet. But then it falls into a temperature inversion again, where as it's getting closer to the ground, temperatures are getting colder and colder. And in fact, it's a pretty thick temperature inversion, and with a pretty thick layer near the surface where the temperatures are below freezing. Maybe it falls for a minute through air that is below freezing, and that's enough time that at least the outside of the drop has frozen, and it'll reach the ground in the form of a little ball of ice that is a frozen raindrop that is sleet. Notice that the key here, if I can make my slide advance, there we go. Notice that the key here is you, once again, have to have a temperature inversion in order to get sleet. There's no way you're going to have, that's the only way it'll happen, that you'll have fallen through some warm air and melt the ice crystal, but then fall through some cold air and refreeze it. And the key here is that it has to be a lot deeper. Now, I deliberately am not going to tell you like how many meters thick and stuff like that, because that is a complicated question under various kinds of conditions. That's, again, like an advanced meteorology idea. But the idea that it's going to have to be a thick layer of that cold air near the surface to form a sleet is going to be important for something we're going to see in a later part of this lecture. I don't want you to get the idea of sleet and hail mixed up. People often will be out in sleet and tell somebody that they're seeing hail. Hail is an altogether different form of precipitation. Hail is a warm weather, summer weather phenomenon. Sleet is a winter weather phenomenon. Hail forms in thunderstorms. Sleet is just frozen raindrops. It can be any kind of gentle precipitation. It doesn't have to be a thunderstorm. Hail is specifically a severe weather phenomenon. In fact, hail is one of the ways we could define what constituted a severe thunderstorm, if you remember from your previous module. Whereas sleet is in general not a severe thing. Nobody's going to be injured by the sleet hitting them. You're not going to damage your roof due to sleet or so on. You might have a driving problem, but the sleet itself falling is not what's causing the damage. Hail is in general bigger than sleet too. I mean, even small hail would be like pea-sized, whereas sleet, it's like gravel or something like that, or they're just even like sand sometimes. They're very, very small. They're just a frozen raindrop. So they're going to be considerably smaller. Alright, now that we've seen 4 types of winter precipitation, we're going to be doing something with them and learning about where they happen in winter storms and so on. But before we do that, let's answer a couple quick questions about the winter precipitation that we've seen so far. Question 5. Which of the following types of winter precipitation requires the presence of a temperature inversion at the surface in order to form? Is that snow, rain, freezing rain, or all of them? Make a choice from those 4 options and get a little feedback before you move on to question 6.